Hi, today we are going to be finishing up our unit on linear equations. Next week we're going to move on to non-linear equations. So the last thing we're going to look at is how to write an equation from a graph. So I'm going to go through the steps on how to do your work today. First step is going to be to find 2 points on the line that cross at corners to avoid fractions. And I'll explain that when we do a couple of examples. And if possible, we want to use the y-intercept as one of those 2 points. Now, if that y-intercept happens to be a fraction or a decimal or not visible, then we don't get to do that. But there's a shortcut if the y-intercept is a whole number and we can see it. All right, step 2, find the slope. So we got 2 points on the graph. We can count our rise and run. If we were lucky enough to have the y-intercept that was a whole number that we could see, then we can just simply write the equation in slope-intercept form right now, and we'd be done. But you're not going to get that today. You're not going to have a nice y-intercept, or it's not going to be visible. So if that's the case, we have to go on to step 3. Step 3, we need to pick either point. It doesn't matter which point we pick, and we use point-slope form. All right? Then we solve for y. We get that y by itself in that equation. So let's do a couple of examples. All right, in the first one here, again, step 1 is to find 2 points on the graph, and this one's already been done for you. The next one we'll find them ourselves, but again, this one's easier. It's already been done. Notice that those points are on corners, not out in the middle, like this point right here. That would be a bad point, because what fraction really is that? It's hard to tell for sure. All right, so that was first step. Now, unfortunately, again, you can see that we did not have a y-intercept. The graph never crossed the y-axis, so we don't see that one. If there was, again, there's a shortcut. All right, so step 2, let's find our slope. All right, slope is counting rise over run. So if I counted from the left dot, I would be counting up 1, 2, 3, 4 spaces. There's my rise, up 4, so it's positive. And to the right 1, also positive. Reduce that fraction. Now, you might be asking yourself, what if I went the other direction? What if, instead, I had started at the top dot and counted down and then over? Well, if I had done it that way, my slope would have been down 4 spaces and then to the left 1 space, which when reduced is the same number 4. I could also double check that any time just by looking at the graph and seeing that from left to right, that graph is moving upward, meaning that it must have a positive slope. Now again, if we knew what the y-intercept was, we'd be done right now. We would just be putting in y equals, we know the slope, 4x. If we had the intercept, we would be done. But since we don't have that y-intercept, we have to do another couple of steps. A third of those steps would be to put it in point-slope form. And now you could use either point, it doesn't matter. I'll pick this one. That has the coordinates -2, 1. So I'm going to now write it in point-slope form. Y minus my y1 coordinate, my y1 coordinate's right there, 1, equals m, 4. And then x minus my x1 coordinate, which is here, -2. When you minus a negative, that's going to act like a plus. Now the last step is to now get that solved for y. Let's get the y all by itself. Now I'd have to get rid of some parentheses here first. So we'll still have y minus 1 on the left. On the right, I'm going to have 4x plus 8. And then to finish off, I'm going to add 1 on both sides. So y equals 4x plus 9. So that was the piece I was missing earlier. If I'd have known that that was the intercept, I'd have been done a long time ago. Let's try one more. Now in this one, we're going to have to find our own 2 points. So I'm going to find this line, and I'm going to follow it till it looks like it hits at a corner. And I'd love it if that spot was the y-intercept. But sadly, no, that's not a nice spot. I can't tell what that number really is. So I'm looking for another spot, and I see one here. Looks like there's one there. It looks like there's one there. And maybe even up here. Now, I don't need all of those. I just need 2, so I can count out my slope. But it doesn't matter which 2 I use. When I'm counting out my slope, say I use this one and this one. It would be a down 1, 2, 3, so down 3, and then right 2. Well, if I'd picked the next two, it would have been down 3, right 2, down 3, right 2. I mean, that pattern and slope continues forever. Now, you might be asking again, what if I'd gone the other direction? What if I'd taken this point that's right here and this point that's right there, and I'd gone up first? Well, that would have been up 3 and left 2. I don't know how many times I can say this, but some of you are never going to catch on completely. But there's 3 ways to write a fraction. Put the negative sign up in the top with the 1, or you can put a negative sign down in the top with the 2, or you can put the negative sign out in front of the fraction. So again, 3 different ways to write a negative fraction. Doesn't matter which side gets the negative. If there's one negative, it means it's a negative fraction. All right, next step. Again, if we knew what that y-intercept right there was, we could go ahead and write the equation now, but I'm not quite sure what it is since it's in the middle. So let's go ahead and pick a point. Doesn't matter which point I pick. I'm just going to go ahead and pick this one that's in the bottom right here. That would be at 3 and 1, 2, 3, down 4. So that's its coordinates. So then I'm going to plug that into my my point slope form, y minus y1, y minus negative 4, it'll act like a plus, equals m, that's my 3 over negative 2, times x minus my x coordinate, which was 3. All right, so if I'm going to solve this for y, I need to get rid of these parentheses first. So y plus 4 still on the left. Now the 3 over negative 2, or negative 3 over 2, either one, times x. Can't really do anything with that one. And then the next one, remember I make the 3 a fraction, so it matches. So I multiply my numerator. That'd be 3 times negative 3. That'll get me a negative 9. Denominator, negative 1 times 1, or negative 2 times 1, sorry, makes negative 2. And when I have a negative divided by a negative, that's going to act like a plus. It gets a little messy. All right, now I'll need to minus 4 on both sides. Y equals 3 over negative 2x, and then 9 halves, which is really 4 1/2, minus 4 is getting me 1/2, or 0.5. Again, if you change those into decimals, that is perfectly fine. But we always want to leave this one in fraction form, because that's the slope. That's always going to be a fraction if possible, rise over run. But this one, if you would have put 0.5 there, would have been completely normal. And that should make sense. If you go back and look at the graph, that looks like that crosses at about 1/2, or 0.5. All right, this is your work today. There's like 5 of these problems, I think, so they're a little time-consuming in this portion. But, again, the idea, it needs to be done. We need to be good at this type of stuff. All right, good luck today.